thermodynamics, all that kind of stuff. So this is basically the same process, except for with momentum. So conservation of momentum is the momentum of a closed system is constant. When we say closed system, what it means is we're not taking into consideration external factors. We're not going to do friction, heat. If this is a collision and a bird flies by and poops on it, we're not going to have to calculate in that math now too. It's a closed system. We're going to ignore all that. So what that basically means is that the momentum before is equal to the momentum after. Remember, momentum is abbreviated with that lowercase p. So today when we talk about collisions, we're going to talk about when they are apart. A lot of people in a lot of classes will refer to this as an elastic collision because they are going to come together, hit, and bounce off. Because in level physics, we aren't going to be calculating out friction and energy loss to heat, sound, or any of that stuff. The term elastic really doesn't apply. The only truly elastic collisions are those molecules in like an ideal gas and stuff, kinetic molecular theory, and we're just not going to go into it that deep. So you're welcome. But this is when two objects are not stuck together. It seems pretty straightforward, but it's when they're going to come, they're apart before and apart after. So our equation, m1v1 plus m2v2, this is basically the momentum of object 1 and the momentum of object 2. It does not necessarily matter which one you make object 1 and which one you make object 2, but you have to stay consistent with it. And you have to watch your directions. Remember, velocity is that vector, so direction is going to matter. All right, so it says two billiard balls. They each weigh 0.2 kg, collide. Ball 5 has a velocity of 6, and ball 1 is at rest. So ball 5 is moving this way. Ball 1 is not moving. So first thing we got to do is list what we have. They both weigh 0.2 kg, so we're going to fill that in. I'm going to set ball 5 as my first object, so that's going to be a 6 and a 0. So what we're going to do is find the momentum before the collision first. M1, V1, M2, V2. And all you have to do is plug. Okay, 0.2 times 0 is going to be 0. So we don't have to worry about that. And 0.2 times 6 is 1.2. So my total momentum before the collision is 1.2.
So isn't it 1.2 after?
It will be 1.2 after, but we're not actually looking for the momentum after the collision. It once says after the collision, ball 5 stops. So now that one stopped, and it wants the velocity of this one. So we're going to do M1, V1, M2, V2. Again, now we're just going to use the values for after that collision. The masses aren't going to change in this type of collision, so they're both 0.2. Your equation should look like this: 0.2 times 0 plus 0.2 times v. That goes away because 0.2 times 0 is 0. And what we're left with on this side is that the momentum is equal to 0.2 v. We know that the momentum's equal, so I'm actually just setting them equal, and I'm going to solve for my v that way. So I'm going to divide both sides by that 0.2. It's going to give me what? 6. Because 1.2 divided by 0.2 gives me 6. All right, there is some typos in here. I just ended up changing the diagram a little bit, and I didn't change the wording. Everywhere it says ball 1, I want you to change it to ball 3. I think there's 2 places. All right, what if ball 8, same mass, so we're going to put in 0.2, is going 4 meters per second, and ball 3 is going 1 meters per second in the same direction. Ball 3 after the collision goes 2 meters per second. Was the velocity of ball 8. So I know their masses haven't changed. So what I'm really looking for is that V1 after. So then I'm going to fill in what I know. And just to keep everything separate, I like to solve for my sides before I start combining anything. So 0.2 times 4 should be 0.8 plus 0.2 times 1 is 0.2. 0.8 plus 0.2 is 1. Well, no. So the total momentum before the collision is going to be 1. So we know that after the collision it's going to be 1. So I have 0.2 V plus 0.4, correct? All right, I cannot combine those. This has a V attached to it. I cannot combine them. We have to combine like terms. Yes, those are no longer like terms. So when I set them equal to each other, 1 is equal to 0.2 V plus 0.4. I'm going to subtract. So to get something to the other side, I've got to do opposite. So minus 0.4 minus 0.4. So now I have 0.6 equals 0.2v. I'm going to divide both sides by 0.2. And it's going to be 3 meters per second. What do you think? We've done worse, right? We've done worse. All right. You'll never believe me. We have one more equation. We have the the together equation, and then that's it. We spend the next 2 weeks practicing. All right, I want you to try to fill in the variables on each side for me on this one. M1, V1, M2, V2. Don't solve yet because we want to make sure they're right. I'll give you a second. All right, so I'm going to use my diagram because honestly, if I have one, I prefer to use them. It says a 10 kilogram mass traveling at 2. So we know it's going to go this way. Meets and collides elastically with a 2 kilogram mass traveling at 4 in the opposite direction. Now, because it's going to the left, it's an opposite direction, we have to use that negative velocity.
Like if it's going to the left?
If it's going to the left, or if it's going down, we designate those as negatives. In this case, because they're opposite, it has to be an opposite sign. Find the final velocity of the 2 kilogram mass. So that one's going to be my question mark. If the 10 kilogram mass goes negative 4. Again, think about how these are going to collide once they hit. This 10 kilograms is going to go back the way it came, and the 2 is going to go back the way it came. But now if you look those directions, that sign's going to be different because, again, to the left is going to be negative, to the right is positive.
So then the first one's negative? Yeah.
This one after the collision is negative, yes. So we put negative 4. All right. Same thing as before. What is my momentum before the collision? Total. 12? Sum up with 12, and then after you should get negative 40 plus 2v. Before is going to equal after. So I can write 12 equals negative 40 plus 2v. How do I get v by itself?
Add 40.
I'm going to add 40 because you have to do opposite to get across that equal sign. So plus 40 plus 40 becomes 52 equals 2v. Because 12 plus 40 is 52. And then you're going to divide both sides by 2. And it's going to give you 26. No, right? Yeah. Meters per second. Now, that's a lot bigger of a velocity than the other ball has. But you have to think of it this way. Okay, I'm not a small person by any means, but compared to like a sumo wrestler, I'm good, right? And so if I was in one of the rings with a sumo wrestler, we're not going to wrestle because I don't like to cry in public. But let's say we are on opposite ends of the rings and we just run towards each other and hit. We're both going to go backwards a little bit, right? Because I have less mass, I'm going to go flying backwards. He's going to take a step or two back. That difference in the momentum. That is why if you get in a wreck with a Honda Civic, your car is going to be a little damaged, depending on your velocities, and it's going to, your mom and dad are going to be mad, all that stuff. If you get into a wreck with like a semi-truck, I hope you didn't like the color of your car. Because that semi-truck has more mass, and so its momentum is going to be a lot greater. So that's exactly what this is showing. All right, second one. M1, V1, M2, V2. All right, so 17. Ooh, that's very close to my 1. 17 kilogram mass traveling at 6. So it's going to be going this way, so it's positive. Meets and collides elastically with a 15 kilogram mass traveling at 8 in the opposite direction. Oh, no, that's 15 and negative 8. Don't forget that negative. This is not worded the best, and that's on me. I apologize for that. It says find the velocities of the 17 kilogram ball if it goes negative 5. And it doesn't really necessarily tell you which ball that applies to. But if you notice, that velocity is negative. These two balls head towards each other. Basketball is going to go that way. Soccer ball is going to go that way. This basketball is the one with the negative 5 because it's going in that negative direction. Before equals after. M1 V1 plus M2 V2. M1 V1 plus M2 V2.
Can your momentum be negative?
Mm-hmm. So you should end up with 102 plus negative 120. I'm going to combine those, and I'm going to get negative 18. I've got to see what I can do on my other side here. So that was 17 and negative 5, and that was 15 and a question mark. Okay, I cannot combine those like terms. They're not alike. One of them has a V, one of them doesn't. But what I can do from here is set my before equal to my after. So I'm going to have negative 18 is equal to negative 85 plus 15V. What's my first step? I want to get rid of that 85. I got to add it because it's a negative, so I got to do opposite. So plus 85 to both sides. I'll draw an arrow over here because I'm out of room. Should end up with 67 equals 15V. I'm going to divide both sides by that 15 because I want my velocity by itself. 67 divided by 15 with some rounding is going to give you around 4.5 meters per second. Okay, tomorrow we're going to practice this some more. The only thing that I have to add to this before the test in 2 weeks is what if the masses get stuck together? Like what if the cars crumple and they're locked together? What's their velocity? Or instead of the sumo wrestler and I running and bouncing, what if he hugged me? Then what would be our velocity? And there's a way that we're going to do that on Thursday. Does anyone have any, well, these aren't technically elastic, right? So they're nearly elastic. Those would be what we call inelastic, though. Are there any questions over this?
What about like gravity? Does that do anything? Because like with the planets, right? If they're around the sun or something, wouldn't that like?
If you're using it, if you have your gravity as a force, it could affect your